Hello and welcome back to Math 1324. We are still in Chapter 4, which is Systems of Linear Equations and Matrices. And today we're going to talk about Section 4.4, which is Matrices Basic Operations. So let's go look at addition and subtraction. For matrix addition, two matrices are equal if they have the same size and their corresponding elements are equal. So we say that they are matrices are equal. Okay, the second blank, the sum of two matrices of the same size is the matrix with elements that are the sum of the corresponding elements of the two given matrices. In other words, they're of size 2 by 2. So the matrix ABCD and the matrix WXYZ, notice that I said they are both 2 by 2 matrices. The sum of those two matrices will also be a 2 by 2 matrix, and all you do is add the corresponding elements. So A plus W, and then you would also have B plus X, and so on. So let's go do some examples. Number one, they are both 2 by 2 matrices, so you can find that sum. The very first element would be 1 plus -5, which is -4. -5 plus 0 would be -5. 8 plus 9 would be 17. And 2 plus -2 would be 0. Example number 2. These are both 2 by 3 matrices, so you can do the matrix addition. Your answer will be a 2 by 3 matrix with elements 0 plus 11, 6 plus 0, -3 plus -4. That's row 1. Row 2 would be -7 plus 4, and then 1 plus 3, and 5 plus 9. For example number 3, this first matrix is a 2 by 3. The second matrix is a 3 by 2. Because those matrices are not the same size, we're going to say that that matrix addition is not possible. Let's look at a couple of properties of matrix addition. If A, B, and C are matrices of the same size, then matrix addition is commutative and matrix addition is associative. Okay, for the commutative property, A plus B is the same as B plus A. So it does not matter what order you add matrices in. Also, matrix addition is associative, meaning you can add the matrices A plus B first. You can add A plus B first and then add matrix C, or you can add matrix B plus C together and then add it to A. So matrix addition behaves like we're used to addition behaving, is the point I want to make. Okay, let's look at matrix subtraction. A matrix with elements that are all zeros is called a zero matrix. For example, a 2 by 2 zero matrix would be that matrix. A 1 by 2 zero matrix would be that zero matrix, and so on. So it's a matrix that has all zero entries. Okay, the negative of matrix M, denoted by negative M, is a matrix with elements that are the negatives of the elements in M. For example, if M is the matrix 1, 3, negative 4, then the negative of M would be negative 1, negative 3, positive 4. Okay, for matrices A and B of the same size, matrix subtraction is defined as follows. If you do matrix A minus matrix B, that's the same as saying matrix A plus the negative of matrix B. This is how you were taught subtraction way back when, if you think about it. You don't really subtract two things, you add the negative of the second thing. So the rule, the matrices have to be the same size to be able to do matrix subtraction. If you do, you're literally adding matrix A plus the negative of matrix B. When you do that, you're going to have A plus negative W, B plus negative X, and so on. Let's look at some examples. Number 1, 1 minus negative 5. So 1 minus negative 5 would be 6. Okay, if you have a hard time doing that negative, you can do this. Plus, plus, minus, 0 stays the same, plus. So I have 1 plus 5 is 6. Negative 5, oops, negative 5 plus 0 is negative 5. 8 plus negative 9, is negative 1. And 2 plus 2 is 4. Number 2, sorry about that. Just to do a quick mental check, this is a 2 by 3 minus a 2 by 3. I can do that subtraction. The answer would be, I'm going to go do this, negative, 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 positive, negative. 0 plus negative 11, 6 plus 0, negative 3 plus 4, negative 7 plus negative 4, 1 plus negative 3, and 5 plus negative 9. Number 3, this is a 2 by 3. This is a 3 by 2 matrix, so this subtraction is not possible. Example number 4, find A, B, C, and D so that that statement is true. The statement says matrix A, B, C, D minus matrix 5, 1, 8, negative 2 equals matrix negative 2, 5, 8, 2. Let's line up the top left elements. Before I do that, let's change this to a matrix addition and find the negative of that second matrix. Now let's line up the elements. A plus -5 equals -2. A plus -5, plus -5 equals -2. So that says A minus 5 equals -2. If I add 5 to both sides, then I get A equals 3. The next one says B plus -1 equals 5. So B minus 1 equals 5. Adding 1 to both sides, I get that B equals 6. C plus -8 equals 8. That says C plus -8 is just -8 equals 8. Adding 8 to both sides gives me C equals 16. Last one, D plus 2 equals 2. D plus 2 equals 2. Subtracting 2 from both sides gives me D equals 0. So the answer to that problem, A equals 3, B equals 6, C equals 16, and D equals 0. Okay, let's look at a product of a number K and a matrix M. So the product of a number K and a matrix M, denoted by K times M, is a matrix that's formed by multiplying each element in the matrix by K. So number 1, 7 times this matrix. So I need to multiply every element in the matrix by 7. 7 times 3, 7 times 4, 7 times -5, 7 times -2, 7 times 9, and 7 times 1. So when you multiply a matrix by a scalar, a number out front, you multiply every element in the matrix by that number. So number 2, I have the number 4 out front, and I'm multiplying it by the 1 by 4 matrix, -9, 2, 0, 8. So my new matrix, 4 times -9 is -36. 4 times 2 is 8. 4 times 0 is 0. And 4 times 8 is 32. Okay, now we're going to go look at a matrix product. So a product of a row matrix and a column matrix. Something I want you to notice. The product of a 1 by n row matrix and an n by 1 column matrix is a 1 by 1 matrix given by, here's your formula. Now, I'm not going to read that out. What I want you to notice is that you're going to take the first element in your row matrix, multiply it by the first element in your column matrix. Then you're going to put a plus. You're going to take the second element in your row matrix and multiply it by the second element in your column matrix. Plus all the way until the nth element of your row matrix and your nth element of your column matrix. Now, something to point out. The number of rows in the row matrix, the number of columns in your row matrix has to equal the number of rows in your column matrix. Those two numbers in the middle have to match up. Here's an example. This is a 1 by 4 matrix. This is a 4 by 1 matrix. These two numbers match, so we can do this matrix multiplication. This will be the matrix -9 times 2 plus -2 times 3 plus 0 times 4 plus 8 times -1. So that is the matrix. What is that going to be? Hold on. Okay, -18 plus 6 plus 0 plus -8. I get -20. So I get the 1 by 1 matrix, -20. Now, I want to show you how to do this using technology. Remember how you enter a matrix? I'm going to go second matrix and edit. My matrix A was a 1 by 4. And matrix A is -9, 2, 0, 8. -9, 2, 0, 8. Okay, second quit. Now go enter matrix B. Second matrix, edit, down to matrix B. Hit enter. This is a 4 by 1 matrix. And the elements are 2, 3, 4, -1. 2, 3, 4, -1. Second quit. All right, now I want to say matrix A times matrix, arrow down to B and hit enter. Matrix A times matrix B is the 1 by 1 matrix, -20. Now let's go look at the product of two matrices. And this time we're not going to specify a row matrix times a column matrix. Definition: if matrix A is M by P and matrix B is P by N, then the matrix product of A and B, denoted A times B, is an M by N matrix whose element in the ith row and jth column is the real number obtained by the product of the ith row of A and the jth column of B. If the number of columns in A does not equal the number of rows in B, the matrix product is not defined. In other words, when you do A times B, those P's have to match up, and the resulting matrix will be an M by N matrix. I'm going to do one matrix multiplication by hand, and then I'm going to tell you we're going to go to the calculator. All right, just checking to see if we can do this. This is a 2 by 2. This is a 2 by 1. So yes, we can do the matrix multiplication, and our answer is going to be a 2 by 1 matrix. Okay, so we should get a 2 by 1 matrix. For the first element, I'm going to do that row times that column. I get 3 times 1 plus 4 times 5. So what is that, 23? For the second row, I'm going to do this row times that column. 1 times 1 plus 0 times 5. 1 plus 0 is 1. My answer is the 2 by 1 matrix with first row 23 and second row 21. Let's go look on our calculator. Second matrix, edit matrix A. It is a 2 by 2, and the matrix is 3, 4, 1, 0. Second quit. Now go enter in matrix B, matrix edit B, and it is a 2 by 1 with elements 1, 5. Now to do the matrix multiplication, I'm going to do second matrix A times second matrix B. Hit enter. 23, 1. Okay, let's go look at number 2. This is a 2 by 1 matrix. The second matrix is a 2 by 2 matrix. Because those two numbers don't match up, the number of columns of the first one, the number of rows of the second matrix, that multiplication is not possible. So from example 1 and 2, do you see that we had A times B here and B times A here? Matrix multiplication is not commutative. In other words, A times B is not equal to B times A. Let's go look at number 3. Let's check to make sure we can do it first. This is a 2 by 2, and this is a 2 by 2. Because those two match, I can do the multiplication, and my answer will be a 2 by 2 matrix. Okay, let's go do this one on the calculator. Second matrix, edit A. It's a 2 by 2. 1, 2, 3, 6. 1, 2, 3, 6. Second quit. Second matrix, edit B. Enter. It's also a 2 by 2 with entries 2, 6, -1, -3. 2, 6, -1, -3. Second quit. All right. I want to do matrix A times matrix B. Hit enter. What do you notice? I get the 0 matrix, 0, 0, 0, 0. So the note down below, the 0 property does not hold for matrix multiplication. Remember what the 0 product property said in the reals? That if you had A times B and it equaled 0, then either A equals 0 or B equals 0. That's not true with matrices. In other words, it is possible to find two non-zero matrices such that their product is a 0 matrix.